Statisticians use statistics to summarize a set of numbers. One of the things of interest is something called a measure of location. And one of the terms for measures of location, another term is the measure of central tendency, and that's just what the numbers tend to center around. There are three common measures of central tendency that I want to mention today. The first is called the mode, and the mode is simply the most frequent number in the set of numbers. For example, if you had these numbers 3383158888, the mode is 8 because there are 4 8s, and that's more frequent than any other number in the set. Now, it's possible for a set of numbers that have two modes. In other words, if there were 4 8s and 4 7s, then the distribution would be called bimodal. So it is possible to have more than one mode, but assuming that there is one number that is most frequent, that number is known as the mode. Another common measure of central tendency is called the median. The median is the middle number in value in the set of numbers. For example, using the same set of numbers that I did before, in order to find the median, you need to put the numbers in order. And looking at these numbers in order, you can see that 5 is the median because there are 4 numbers to the left of 5 and 4 numbers to the right of 5. It might occur to you though that sometimes there is no single middle value. In other words, if there are an even number of numbers, then there is no single number in the middle. What do you do then? For example, going back to the previous set of numbers, let's add a 10th number, say the number 9, and put them in order. Now you can see that you have 5 is the 5th number, and there are 4 numbers to the left of 5 and 5 numbers to the right of 5. So 5 is not the median. What you can say, though, is that 5 and 8 are the two middle numbers. So when there are an even number of numbers and there's no single number in the middle, you simply take the two middle numbers and take the average of them. So here, for instance, since the two middle numbers are 5 and 8, you would add them up and divide by 2. And that would give you 13 halves, or 6.5. So the median would be 6.5, the average of the two middle values when there is no single middle value. The third common measure of central tendency is called the mean. And the mean is simply the ordinary arithmetic average of the set of numbers, the same average you've known how to compute for years. For a lot of mathematical and statistical reasons we're not going to go into, the mean is much more common than the other two measures of central tendency. And so we're going to create some notation for that. We're going to use the symbol x bar, x with a horizontal line above it, to stand for the mean. And the mean is simply the sum of the x values. In other words, you add up the x values and divide by n, which is the number of x values. You add up how many numbers there are in the set and then divide by that number. It's the ordinary arithmetic average. For example, going back to this same set of numbers, if we want to find the mean, then we add up all the numbers and divide by the number of numbers. So we add them all up. Since there are 9 numbers, we divide by 9. We do the arithmetic, and you find out that the mean of this sample of numbers is about 5.22. Now, there is a distinction here that I want to make note of, and that is everything that I've said so far assumes that this set of numbers that we're talking about is a sample from some larger population. For example, the x's might be these might be 9 scores on a quiz, and I just took a sample of 9 students in a class of, say, 200. In that context, this x bar stands for the sample mean. It's the mean of the numbers in your sample from a larger population, and that population mean is called mu. The Greek letter mu stands for the population mean, and x bar stands for the mean of the sample that was drawn from a larger population. Also, a fact that I'll state without proof, but that is very important, is that the expected value of x bar is equal to mu. In other words, the expected value of the sample mean is the population mean. And that's very important. It's also very common sense if you think about it. You would expect that if you took a random sample of, say, test scores and averaged them, that you would get somewhere close to the actual mean of the entire classes average on that quiz. So the expected value of the sample mean is the population mean.